Hook one of those. Pull it on the bolt on the bottom. Just unhook it there if you can. It's tight though with the wind. Yeah, and then just go start unhooking the ends. Okay. No, no, just let it all go, and then go to the actual shade. And at each of the corners of the shade, there's a hook that comes right off. Do you have it or no? Do y'all have it? Okay. All right. Yeah, I almost took it down before I left, but I was like, if I take it down, it's not going to rain. Huh? The sad thing is, I don't even think it's going to hit us. I think we're just getting the gust front. Oh, well, hopefully we will. Okay. Well, you might want to tell her to, yeah, yeah, yeah. Okay. Yeah, the chairs will be okay. Okay. No, now you know how to do it. All right. Love you. What time did I break? 6:42. 42? Okay, another 30 seconds. Oh, that is rain. That's heavy. That's heavy rain.
Oh, bro, thank God.
Good. Maybe it'll rain for a little while.
Bro, I'm so dumb. I have an umbrella in my car.
It's not going to be that long. Yay. We're actually getting rain. That's weird. The satellite doesn't show any rain, heavy rain over us right now. That's weird. Okay, I'm gonna keep going. All right, so we have the objective is to find the maximum area, right? We drew a picture, we have a formula for the area. The formula was in terms of two different variables, x and y, but we have this constraint that's going to allow us to now solve for either x or y. So I'm going to solve for y. How about I divide everything by 2 first, and then subtract x on both sides. And so now I know that y has to be 50 take away x.
This is all under the constraints.
This is all under the constraint, yep. So now I have a formula for y in terms of x, right? So for this particular rectangle, y has to always follow this formula. So I can go back over here to the area, and I can replace the y with 50 minus x. And now notice my area depends on one variable, right? It depends on x. In fact, we could look at this as being a of x is 50x minus x squared. And this is the objective function. See, we started out with the objective of maximizing the area. We had an area equation. But now we've reduced that area equation into an area function. And that is the objective. We want to know the maximum that this can be, right? So we have a function, and we're trying to find its maximum. We know how to find global max and mins, right? If it's closed interval, and we know how to find local max and mins if it's open interval. So now what we need to do is think about the variable x, what it represents in this problem, and whether or not that x has a restriction that's closed interval or open. So is there a smallest value that x can be for us here?
It has to be greater.
Does it have to be greater than 0? Can it be 0? Could x be 0?
Yes.
This is a little subtlety. Students always have trouble with this part. Let's say I was going to go build this, right? And I have my x's that I'm going to build, and then I have my two y's, right? I'm going to build these, and I'm put them together. Could I let x be 0? And then use 50 feet here and 50 feet here? I could, but, right? I mean, that's stupid, though. But that would be the absolute, smallest x could be.
So you can't go negative.
Can't go negative, though. So right now, I can say that the domain of this is x has to be between 0 and, what's the biggest x could be? 50, not 100, because you have to have both sides built. So 50 here, but again, that leaves nothing for y, but this is the extreme case, 0 to 50. Hey, that's a closed interval, isn't it? That's a closed interval. And since it's a closed interval, I'm going to use the closed interval method to find the global maximum of this. Understand? So let's do it. You remember the closed interval method? We take the derivative, don't we? Take the derivative. That's an easy derivative. 50 minus 2x. What do we do with that derivative? Set it equal to 0. Figure out where it doesn't exist. That doesn't happen because the derivative is nice. But setting it equal to 0, well, that's not that bad. 50 minus 2x equals 0. You get x is 25. I trust that you could do that, yes? Now what?
Put it in the number. No, number one.
So it's closed interval method, right? Right, this closed interval? Since it's closed interval, what we're going to do is we're going to take this answer and the two endpoints and plug them into the original function. And then which is the biggest, and that's the only one we need is the biggest, right? So this is the closed interval method. We have to make sure we're doing that. So I need to find a of 25, a of 0, a of 50. All right, so plug 25 into the area function. I'm going to plug it in right here. I could do here or here. Doesn't matter which one. I think it might be easier to plug it in here. Right? Do y'all see that? 25, 50 minus 25 is 25. What's 25 squared? 625, I think. So this is 625. What happens when you plug in 0 into the area function? You get 0. What happens when you plug in 50 into the area function? You get 0 as well. Those are those two extreme cases, right, where we used all of it for one side or all of it for the other. Is it easy to see the max here? Yeah. This is your max, right? Now, what did the original question ask? I've erased it. What did I ask?
Find the dimensions.
Find the dimensions, right? So right now we know we're going to build a rectangle. We know that this was x and y, and we've found that we get a maximum area of 625 square feet if x is 25. So we need this to be 25. And now, what's y? Well,
Back into x.
yeah, come back over here to the constraint, and now you can solve for y by plugging 25 in here, so you get 25. So basically, we need to make a square, right? Any questions? The dimensions are 25 by 25. What?
Was the answer on the text? How would we find? Like, what was
X equals 25, y equals 25.
Wait, did it initially ask for a rectangle, or just?
That's a good question. Is a square a rectangle?
Yes,
It does qualify, so
but a rectangle is not a square.
not not arbitrarily, right? A rectangle is not necessarily a square, but a square is necessarily a rectangle. I'm going to change the problem. Okay? Find dimensions of rectangle with area of 100 square feet with minimum perimeter. Yes. This problem looks a little bit like the one we just did, but it's very different. We want to make a rectangle, right? Rectangle. Okay. Rectangle. All right. So we want to construct a rectangle, but this time we have a fixed area, right? Not a fixed perimeter. The perimeter is not 100, the area is 100. So what is the objective here?
A equals, oh,
The minimum amount for
You want to find the minimum
of the perimeter.
perimeter, right? You want to minimize the perimeter. I'm going to put P for perimeter, right? We want to minimize the perimeter. Okay, let's draw a picture. X, Y. What's the perimeter of this? 2x plus 2y. Okay, right now, we can't do any derivatives or anything because we have two variables, right? X and y again. But we have a constraint. What is our constraint this time? The area has to be 100, right? Do y'all see? I'm doing these two problems on purpose to see, so you can see the difference. What is the area, though, for that rectangle? X times y, right? X times y. So we have x times y equals 100. Can you solve this for x or y? Can you get y or x by itself?
yes.
Let's get y by itself. Divide by 100, right? I mean, sorry, divide 100 by x. Right? So what I can do now is I can go to this formula for p. I can replace the y with 100 over x. Making sense? Let's clean that up. Notice the perimeter has just x's in it now. So my perimeter is a function of x. It is 2x plus 200 over x. This is my objective function. What now? I have the function I'm trying to find the minimum of, right? Domain. Domain is the next step. Do not forget this step. This is the step that everyone messes up. You need domain because that's going to tell you open or closed interval method or open interval method. So tell me about x. You must have an area of 100, right? How small can x be 0?
No.
No. Why? Yeah, I mean, x can't be 0. You can see that right here, right? You can see that right here. 100 divided by 0 wouldn't be defined. See, if x is 0, you have no area, and the requirement is you must have 100. Now, could x be just a little bit bigger than 0? Like 0.0001? Sure, I can make this side really small and then make y very long. So x can be everything up to 0. And how big could x be? How big could x be? Could it be 100? No. Could I make a rectangle that looks like this? 100, 1. Does that have an area of